Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and on today's show, we're going to be doing this late night live stream of fun and exciting proportions. We're going to be building a Raspberry Pi Pico with a Waveshare 1.8 inch LCD screen. So let's go ahead and get right into it. So what we see here, I'll move this out of the way, is the Raspberry Pi Pico, right, which is just a small microcontroller, and this is the wireless variant, which has Wi-Fi connectivity as well as Bluetooth, things of that nature. We may or may not, depending on how long everything takes to actually get it working, we may or may not be trying to delve into this today, but I think it's something where there are possibilities associated with being able to have access through the web by creating a small server on this, where it can serve a web page and be able to control certain devices. Adds a lot of flexibility in terms of how you implement it. And part of the reasons I wanted to try this LCD screen, which I got this as well as a few others just like it that I want to integrate into projects, they have the headers built in. So by soldering the headers to the Pi Pico, you can actually just integrate it directly and everything just kind of works. Now, we're going to see how it goes. We're going to see if it's something that we can make work right out of the box. I have a few extra parts just in case it doesn't. But realistically, it should be easy. Famous last words. So, join us for the fun and exciting little experiment as we go through and just try this out. And of course, if you're watching this now, this is a live stream, but if you're watching this after the fact, it's going to be a VOD. So, feel free to ask questions if you're here, but also ask in the comments if you have any questions after the fact. I'll be happy to answer those. So first thing we're going to do is we have to solder these headers to the actual Pi Pico. And the first thing I want to do is actually make sure, and this may be hard to see, so I do actually have a new toy here, which is a microscope. This should make it a little bit easier to read. On the bottom here, we do have the actual labels associated with what each individual pin function is. And using that, we're going to determine exactly which direction we need to go in order to make it work with this. So this is the back of the Waveshare Pico LCD 1.8, and it does tell us our pin numbers as well as some key, which ground pins are which, etc., just to make sure that we have it in the right orientation, because we have two ways that we can possibly solder this. We can solder it like this, so it's facing out, or we can solder it like this, so it's facing in. I have a feeling it's going to be facing in, but we need to verify that before we actually solder it, otherwise we're going to have problems. So we see on this one right here, we see GPIO 14 is located at that location right there, which correlates to 14 right here. So that indicates to us that it faces out. Right? So 14 will match 14. So the pins need to be on the bottom. So we'll go ahead and move the microscope out of the way. We're going to place these on the bottom. And to make it easier, I'm actually just going to use the Waveshare. I'm not going to seat the pins fully because I'm worried about heat. But if you actually look, it will keep them in the right orientation so that way they're straight up and down to be able to mate with this later. So I got that sitting there. I'm just going to be using some solder, some very fine solder, basic pencil soldering iron. In this case it's a Weller. But let's go ahead and get started. I don't think I can zoom in anymore. And I don't want to solder under the microscope because it's just annoying. I don't have a fan set up, but I do have good ventilation in here. So it's going to take all those fumes away. And what I'm doing is I'm trying to apply enough heat to make sure that it is actually getting a good connection electrically. But I don't want it to get so hot that it cooks all of the components and makes the Pi Pico stop working. And the Pi Pico itself is actually this chip right in the center. There's a number of other support components, things like that, and I believe that the actual Wi-Fi adapter, which is underneath this metal shield, is actually, a third party. But the microcontroller is what we're going to be programming, so that's generally how it's classified, since everything else would fall under the purview of the firmware. So that's one side done right here. Let's go ahead and do the other side. And the key thing is, you don't have to be perfect in terms of how steady your hands are or anything else like that. It's just about, making sure that you're not creating solder bridges between pins. Because that would cause a short circuit that could potentially bridge your power pin to your ground, things like that, cause damage to particular components, things of that nature. Alright, and I'm just cleaning off the tip of the soldering iron as I go. So it doesn't look horrible. I'll show it to you. I'm not going to clean it off right now. I'll clean it off camera at a later time, but let's take a look at how I did. And find the focus spot. And just so you know, so it has like the little ridges that are on the sides. Those are actually called castellations, just like on a castle, where you'd have, it would go up, down, things like that, so they could shoot out between. So those little castellations on PC boards are actually so you can put connections on the side without having it going through the through hole. So it's a way to make it like two sizes in one. So it has the through hole size, and then which we're using for the pins right now, but we could actually integrate it as part of using the castellations. So, but we see that all of the connections look bright. We see it does look like it flowed fully through the via, and the via is that little connection that goes between the top and the bottom that the pins will actually sit in. We want it to flow fully through there, otherwise it's not going to make a good mechanical connection, and that's going to cause some problems for us down the road or increase resistance. So we just want to make sure everything's as optimal as possible. And we see the other side looks okay too. There are some discoloration, things like that. That's not actually burning, that's the flux. And I will need to clean that off, otherwise long term it will degrade and actually disrupt the coating on the top of the board. But for right now, for the short term, in terms of saving time, I don't think it's going to affect anything. So we have the USB indication on the bottom of the Waveshare. We have our USB connection right here. And we can see those will seat fully together. And it just holds it, and I think that's a really good form factor and a good package to where you could potentially integrate this into like a box. And I'm planning on doing that at some point. I actually was thinking about doing that as part of the project today, but realistically, it's just going to be a bit much, I think. It's probably going to make the stream a couple hours long, and since it's late night, I'm not sure I want to do that. But this is the smallest box that I could find that could actually hold all of the components that I ultimately want to use this for. And I have pre-tested this, just this board. I do have another one here just in case, but I did pre-test this and preload on MicroPython, which is what we'll be using to actually do our coding today. The Waveshare folks do have an example code that we're going to be taking a look at that will let us try it out without having to do anything. And hopefully that works. And we'll try modifying it and seeing what we can do from there. So I got a USB cable. I'm going to plug it into my computer. We see nothing happens, but the backlight does turn on, which is a good sign. If it didn't turn on and nothing happened or smoke came out, we would take that as a bad indication. So, good start. So I'll switch over right now to the computer view. And what we have here is this is the actual demo, that the example code that they provided to program and make this thing do something. And hopefully it actually shows something nice, but it is an RGB screen, things like that. And so there's a lot of flexibility. So having a library to be able to do a lot of it is very useful. And what I believe that this does is it just shows a little logo with some text. So what would be really nice is if I had if I preset a scene to be able to show everything at once. Maybe I'll throw that together really quick. But let's try loading this. So right now I have the COM connected, but of course it's not showing up. So what I'm going to do is hit the stop button up here. This is Thony, by the way. And Thony is very, you can't see that, but Thony is very good for this type of project, specifically with MicroPython. It'll help you load the initial library to install MicroPython, but then it will also help you edit files, load those and save those, etc. So just for fun, let's just try running it and see what it does. Now if we go back to the overhead cam, because it did run successfully. I have a little too much stuff here. There we go. We see it says Raspberry Pi Pico, Pico Go. And what you're seeing as far as those lines, those are actually, it's called a moire effect. And it's when the pixels are just the right size to have some aliasing issues with the camera that it's looking at. So not a lot I could do here. I mean, I could probably try, we could try the microscope. Let's see. And we see that goes away, and I got to be careful because it's a metal platen. But we see that they're pretty big pixels, but we have a good type of display where it's showing a lot of colors, things like that, that we can potentially modify. So placing that over to the side and looking back at the computer, let's look at how it's doing this. So there's a number of defined functions, things like that, that are built into a class. And a class is just pretty much a combination of functions. And when you call that particular class, you could leverage those functions in a more logical pattern. So if you're going to integrate this into something else, you know, for example, a larger script, it would make it a lot easier to be able to utilize it that way. Instead of just writing it out every time you needed it. You could just call it again. So scrolling through this, we see a lot of writing of data, and these are just hex values, which is the 0x definition. So anytime it says 0x, and then it says a number between 0 and f, which is 16. So A, B, C, D, E, F would bring you up to 16 if you included the regular numbers. So those are 2-digit values. That's equivalent to 1 byte of data. So it's writing 1 byte at a time using hex notation to be able to do that. And it's sending commands and it's sending the data. Then we see, looks like cable select, things like that. This is an SPI device, so it is using SPI write in order to send it out. And then down here, the __main is how it's actually denoting the running function that we saw on the screen. So that we see running here. So this is where it's starting that. So everything else was kind of a support function to be able to get that to run. So we see it has pulse width modulation. Frequency is 1000, which is 1 kilohertz. The duty cycle is going to be 32, so it's going to be 50%, and that's probably for the backlight, if I had to guess. Then we see that it's defining the LCD underscore 1'8". The color for the background is going to natively be white, and then it's going to show the LCD. Then it's going to create the rectangle, so we see the red rectangle. On the top, that is supposed to be red. So we have the red rectangle on the top, and then we have the text, which has white. So, and it says Raspberry Pi Pico. So if we wanted to, we could change that text. And let's go ahead and do that now, just because that's a good place to start. And instead of saying Raspberry Pi Pico, let's say Hello World. Okay, and we're not going to save it, we're just going to run it. And when we do, we see that now our text has changed to Hello World. So we kind of understand exactly what that's doing, and we can make that square bigger, or the rectangle bigger, we can make it smaller, or we could change the color entirely to be able to make it what we want to do with it, So we want to make it, let's say, instead of blue, white, green, let's make it black. Right? And Thony comes up with the auto-completion of what the available options are, which is really nice. And when we push that, oh, sorry, I didn't switch to that screen, but I changed these to black, and I'll just do it again. It comes up with the available options, which you can't see right now, but go figure. I'll work on that. But it comes up with an option list of what functions are actually available to be able to use that. So black is a viable option, and what I'm going to do is hit the run, but I'll switch to overhead cam so you can see what happens when it runs. And we see that now that square changed from red to black. So we've kind of got a good understanding of what we have to do in order to be able to modify this script to make it do what we want. So we can change these other options, things like that. And then it actually goes through, and for these lines down here, it actually is filling those out with a raw hex value. So instead of it being something, and it's not putting any text on it, but we could. So if I actually break these up to kind of emulate the same spacing that we have with the other lines, we can see right here, so starting from 0 and going to 60, yeah, so 60 and 160 in height, it looks like. I'm actually not sure what the specific definition is. Let's see if we can find it. Right, and here we see where the definition of those colors are. So we have white, black, green, blue, and red. And in this case, it does have frame buffer as being brought in as well. So there's possibility that there could be some commands defined within there that it's using in order to do it. And I have a feeling LCD is one of those commands for frame buffer, since this is a pretty typical use case that would apply to multiple types of displays, let alone this one in particular. So I don't actually know what the specific what the specific positional notation of each thing is. Let's actually try and see if it'll show us. No, it's not able to. So normally what would happen is if it knew the command, it would come up with a helper to try and give you an understanding of what values you are filling out. So we're not going to do that for now, but let's take a look. We see that there's some consistent type of some consistent values that are incrementing here. So we're seeing things are 0, starting from 0, which is the top of the screen. So it looks like this is our Y position. My feeling is this is our X position. So let's actually see if we can just type that out as a comment. So I'm willing to bet this is X. So start X, start Y. Then we have end X and end Y. And then we have the color. So how do we get that? So we see here that we have 0 is our starting point across all of these. And if we look at our actual LCD, we see that it's starting from the full left side and going to the full right side. And this isn't a very big screen, so we know it's not going to be, you know, tons of pixels going the full distance, but we see that it's only taking up a little portion at the top. So if we go back over to the code, we see has 0, 0 as our start point, which would be the origin at the top left of the screen. We then see it goes to 160. And in this case, because we can see that the line itself is much wider than it is tall, we would expect the larger number to be our X value. And X is horizontal, Y is vertical. So the 160 we would assume to be the place where we want it to stop. So 160 would be the end of the screen. So then we have 20, which is our stop point for Y, because if we have X, Y to start, we have an X, Y to stop. And 20 is a good guess because we see that it also has 20 on the start point for the Y position for the next line. So I think this is a good bet. So if we actually scroll down here, and I'm going to copy and take this with us, and let's go down to where it starts with the hex values only, we can see that it's 0 is the start point on the x-axis, 60 is the start point on the y-axis. Again, it goes to 160, which is the other side of the screen, horizontally, and it's going to be 10. Let's see, 10 pixels tall. Ah, so it's not end Y. So that disproved it. So it's width and height. So based on that, see, all of these are 20. So I should have actually been able to extrapolate that from there. But we see that they're doing 10 pixels in height for the remainder of the rectangles. And if we look, that makes sense. I don't know if you can see it well. We can try this camera. But we see that it looks like they're half the height for the bottom ones as it is for the top. So based on that, let's try and modify one of these. So let's make it 20 in height. We'll keep it the same color, but I'm going to comment out the next one since technically we're going to be going over top of it, and we don't necessarily want to overlap it in that way. And let's run this and see what we get. And just to say, so I changed this to 20, so from 10 to 20, and then I commented out the next line because we're going to be overwriting it with our same Y position. And now let's go ahead and run it. And we see that lighter yellow color has now gotten to the same size as the ones above it, which had the 20 value for the overall height before. So let's go ahead and try and add some text to that as well. So for the text, we're going to keep it as white currently, but we may have to change that to black just based on what the color contrast is between the background and the foreground. And that's what this is actually saying, is it's the color of the foreground, which happens to be our text. So we're going to change our text. Let's call it test 1, 2, 3, 4, 5, 6. And then we have a 2 and a 48, which I believe are our bounds. And I do believe that would put it inside of the rectangle. But let's just try changing this. So up top we see it goes 8, 28, 48. So it's incrementing by 20. Let's just change this to 68 and see what happens. We'll leave the rest as it is. So now, when we run it, we see it's showing our text properly. And it looks like there's a 2-pixel pad around at the start point. And then it's showing our text. But it's really hard to read because of that contrast issue with the background. The background is too light to be able to do it. So let's go ahead and change this to black. So now when we run it again, now we see it's a lot easier to read. Doesn't necessarily look the best, but it is something where we added a new line that wasn't there before. So, we're getting an understanding of exactly what code we're dealing with and what code we would have to integrate into our own custom script to be able to start using this to be able to generate these types of graphic displays. But let's say we wanted a better color. Let's say we wanted blue. Right, so I just changed that to blue, and when I run it, now we see it shows up a lot better. Let me see if I can hold this up to the camera really quick. Whoops, shorted it out. So it has the exposed pins on the bottom, and I put my finger on it, which caused it to short out. So something to definitely be careful of. And because we didn't have it saved, I have to rerun it. So let me go ahead and do that. And the nice thing is that these tend to be very forgiving in terms of ESD resilience and things of that nature. Let's see, can we get it to focus? It is fighting. Come on, camera. There we go. And just kind of a note about that. So the moire effect that we see when we're further down is only when the pixels of the screen match too closely to the pixels of the camera. So as we bring it closer, they start to fill more pixels of the camera, and that effect goes away. The moire effect. M-O-I-R-E, if you want to look it up. So we see that now we've created that yellow bar and we've created the blue text within it. And we can keep going. But what are some of the possible applications where this can be useful? And some of them, and specifically the ones I want to use it for, is I want to show the IP address. So if we're connecting to Wi-Fi, we don't have to go into the router every time to actually determine what is going to be the IP address that we have to connect to, especially if it's running as a small server. So having it show its own IP address saves us all of that time. Also, we can add things like being able to show what the current time is, some kind of heartbeat to let us know that it's working. That's really a big thing, is because especially with MicroPython and things like that, it's going to be just as susceptible to programming errors as regular Python. So if there's a problem and you don't have a try function, it's going to pretty much exit your script entirely. And that's not necessarily going to be the best. It's just going to be something where it looks like it's unstable, but in fact it's trying to show you a coding issue. And if you don't have a console cable hooked up or a USB cable or some other method to be able to track and troubleshoot those errors, that's going to make it very difficult to be able to try and isolate it and resolve it. So it's certainly something where having the ability to identify at least when it freezes lets you know whether you can rely on it or not, or having some way for it to print to the screen, for example, before it exits when it's unexpectedly doing something, can provide a really great way to catch these errors and try and resolve them, especially without having a computer hooked up. So that's just one of the examples here. So what I actually want to do with this is something that's kind of similar, and we'll probably keep going. It's only been a half hour. So I shove everything out of the way. So what pulse width modulation is it's a square wave. And what happens is you actually adjust the relationship between the on and the off time. And when you average those two together, you will get a value that is between 0 and 100%. So because it's using just the fully on or fully off state, it's not acting like a resistor, it's acting like a switch. Because the problem is when you have resistors, things like that, you have to actually attenuate the current, attenuate the voltage that you're applying through it, and that generates heat. But because you're just in a fully on or fully off state, it's not attenuating the current outright, it's just switching it, fully on, fully off. So there's very little heat generation. And there's components, like for example, in this case, like this is a MOSFET driver, right? And it's an N-type MOSFET. And it will switch incredibly fast. So as fast as you can possibly do it with your pulse width modulation output, it will be able to take this and amplify the current. So you take the small signal coming from your microcontroller, run it through a MOSFET like this, which acts like a larger switch that's remote controlled, and that's going to make it so you can drive a much bigger device. And in this case, I want it to be able to actually control some lighting. So both a 12-volt light and a 5-volt light. And that will make it so I can adjust their brightness so it's not blinding me in the face when I'm looking at it or walking into the room. But because we're using a Wi-Fi enabled microcontroller like the Pi Pico, that's going to allow us to be able to add some additional functionality like Wi-Fi control, and adding it so you can automate the process by integrating it into Home Assistant, or adding motion sensors, or adding push button control through like the Stream Deck, for example, from Elgato. Like that type of thing makes a lot of flexibility because you're building this type of microcontroller for yourself. So let's actually take a look at that. See what I can do here. I'm just checking for things really quick. So we'll switch over to computer. And let's choose a different window. All right, there we go. So what I've been doing, there we go. Perfect. Okay, so what I've been doing is I've been talking to ChatGPT-4, just trying to come up with exactly what I would need. So the original prompt was, hey GPT, I'm writing a MicroPython script for the Pi Pico microcontroller to control 2 LEDs using pulse width modulation. I want to connect to this controller via Wi-Fi and a web page on the Pico, but I would like the Wi-Fi credentials stored in a separate secrets file called secrets.py. I also have a Waveshare Pico LCD 1.8 that I would like to display the IP address and the current brightness for each LED as a percentage. When a change is made, I would like the LED to asynchronously fade from its current level to the new level smoothly, and I would like a separate on-off control that when clicked will turn the light off or back on to its previous set brightness level. It should also reconnect in the event it loses Wi-Fi connection. Can you write that for me? And this is kind of where it came to. Let me see if I can make this a little bit bigger. Hopefully you can see that. So it starts by setting up the libraries, things like that. So it gives us a secrets.py file, things like that. It gives us an example for how to connect to Wi-Fi, which is importing network, importing time, importing secrets. So when we put it in this format, which is pretty much any kind of Python format, we can just include it as a library, and the variables that we set will become available to just use directly in the script. So in this case, from secrets, which is secrets.py, we import Wi-Fi SSID, Wi-Fi password, things like that. And then it defines the function connect Wi-Fi, which then allows us to connect to our Wi-Fi connection. Then we can set up a basic web server, things like that. So in this case, it's going to handle the requests coming in, as well as determine whether we're trying to modify LED 1 or LED 2, and it will actually set what those values are going to be using other functions. Otherwise, we would have to create our own control code. So, it hasn't done that for us yet. We would have to request that from ChatGPT if we wanted to make it, or make it ourselves. But at that point, it's just HTML. So we're just kind of putting whatever we want here. And then it will define the web server. So what it's going to do is it's going to listen on any network address. So that's what the 0.0.0.0 means. 80 is the port number it's listening on, which is the standard web port. And then it's looking for the address, so it's actually filtering it out. Things like that. So it's looking what our current address is, etc. So then we have socket, creating a new socket. It's going to bind to the address that it specifies. So pretty much whatever address we have assigned from our DHCP server from our router when we connect it to Wi-Fi is what it's going to bind to. And it's going to bind to port 80, and it's going to listen for 5 seconds at a time. Or, listen for 5 client connections at a time, which is just a way that it reserves the actual resources needed to be able to parse and handle those particular client connections. But I will say this, in practice, the Pi Pico is not powerful enough to handle multiple clients at one time. It can really only handle one, otherwise it just doesn't work. So just keep that in mind. It's just not very powerful as far as hardware goes, but it is powerful enough to do control, like short commands, things like that. So keep that in mind. You're not going to be serving videos from this thing. And then it's going to loop forever. So it's going to get the client and the address, things like that, as it accepts new connections coming in. The requests, it's going to expect and receive up to 1024 bytes of data. And then the response, it'll handle the request, things like that. So handle request is another function that it's saying, and the response is what's actually coming back. And if we look up here, this is where handle request was defined. So we give it that information, it's going to tell us what folder it's in, things like that, and then it's going to extract that from it, or it's going to return our general response, which has, or actually I should say, and it will return our general response that has our current web page, our current values, things like that already defined. So we would have to put in code here that would pull the values that it currently is back out and then return them back to show the updated values to the user. So that's what that's doing. And then, of course, we want to actually do something with this. So we have the LED control with pulse width modulation and fading. So it's going to use the machine library, which is the physical library that can control the pins. And we're going to want to have pin and pulse width modulation. So we have LED pin 1. In this case, it's choosing pin 0. We could change that to whatever we wanted. And it's going to be an output. Same thing, pin 2, but that's on pin number 1. And that'll be an output as well. And then we want to define that those are going to be pulse width modulation pins. So instead of just being on and off, it's going to be that square wave that I showed you a second ago. So, and we reference those by the pin reference that we defined up here when we defined these pins. Then we want to fade the LEDs. So we have our current brightness is the current LED duty cycle, and the duty cycle is just the relationship between the time that it's on and the time that it's off. With 0, it's 0%, it's off the entire time, and with 100%, it's going to be on the entire time, and pretty much everything in the middle is going to be some proportion in between as it goes between those two. And the current brightness is that the steps are how many steps that we actually want to take in order to get from whatever our current brightness is to our new set brightness. So if we're going between 0% and 100%, it would do it in 100 steps. And that might be a little bit choppy. We could actually change this arbitrarily to 1,000 to add a much finer, fading curve. And it may take longer, things like that, as far as its actual time it takes to get there, because we have a sleep command as it applies it. But, it's something where you choose what you're building this yourself. So it is something where you can choose whether it looks like it's kind of stepping up, but it's going to be a bit smoother if it's something where there's more granular steps in the middle. And then what it's going to do is for each step in the range steps, and when we say range, it's pretty much without any other variables, just a number. It's just going to count from 0 to that number, and it's going to put whatever the current number is in step. That's how the for loop works. So for each step in range, it reads a lot like English Python, which is why it's very well accepted and a very good programming language to learn on. And then we'll see that it'll actually use that in a small little equation that it has here. So the new brightness that it's going to set it to is going to be whatever the current brightness is, which we got from the LED duty cycle, plus the target brightness minus the current brightness times the step that we're on divided by the total number of steps. So obviously when we're at the last step, this will just equate to a 1. So it will times 1 by the difference between our target brightness and our current brightness. So the way that it's actually chosen to implement it here is it will always take the same amount of time based on the number of steps that we've defined to go between any particular brightness. So it doesn't actually have a way for it to, if the values are very close together, so if we go from 50% to 55%, it will take the same amount of time as if it goes from 0% to 100%. And again, it comes down to whether you feel that's acceptable. Maybe you want it to go faster based on what your actual, what the distance is. So you would have it potentially do it by a default static value increase it, and then just keep checking to see if that's the right value or not. So, that's another option to do it, but I think this is very simple, it's very elegant, and keeps it where it is doing a linear fade. And then it's setting the LED duty cycle here. So if we call LED duty without the actual any arguments, as it's called, so without any arguments, it will return what its current value is. But if we set a new argument, and in this case we are setting new brightness, which we just computed, to an integer, and setting that into LED duty, that will set that brightness, set that duty cycle to be whatever we put in there. And in that particular case, it's not a percentage, it's actually a number. I believe up to 65,000. So I have a feeling there's the possibility that there is an error here, just in terms of its implementation, which ChatGPT is not immune to. So in a lot of cases, this is still the cutting edge. So it's something you got to watch out for, and it may error as you actually try and implement it. And then what it's doing here is it's sleeping for 0.01 of a second in between each step. So obviously if we sped this up, it would change a lot faster, things like that. So if we increase this to 1,000, but then added another 0 here, so it's 0.001, we would get a lot more fluidity of the actual thing in the same amount of time. So just some examples of some of the knobs that you can turn. And then for the display, it actually didn't know how to handle it. And I'll come back to that in a second. But it just kind of gave us something generic here based on LCD, clear, and print, things like that. So it assumed there's a library. There is, in fact, a library. We just used it. But it is something where we would want to be able to put something like that in. And then it goes through the main function. So this is the main function where it will connect to Wi-Fi. If it's not connected, it will sleep 1 second and wait until it is connected before getting the IP address. And then it will update the LCD with that IP address and have a starting brightness of 0, and then it will do the try and the accept for the web server. So if it does run into an issue, it should hopefully be able to at least give us an understanding of what it is. And in this case it says pass, but which means it's not going to do anything with it. But we could put that in while loop, for example, and then have the try accept, and it would automatically recover in the event that it ran into an issue. So just some examples there, but I didn't like that. I'm like, can you provide an example where all those elements are in the same script? Because that seems like a lot of work to try and implement it manually. So it gave us this version of code right here. Okay, it didn't fill out everything, but it did fill out a few things. Right? But it still didn't know what the LCD integration was. So what I did is I found the URL of the actual documentation, which happens to be this. So I got it from here. So the demo code, everything else came from here. I gave it this particular link, and from there it was able to pull out the appropriate Python integration code to be able to define it. So it says from this import LCD, and then import colors, things of that nature. And I haven't actually tried this, so let's see if we could try it right now using Thony. But we will have to actually go through and do... See, the nice thing is my cat is going to get me covered in fur, which makes this a lot easier. So let me pull out that initial definition that it gave us for the secrets file. And we'll just pull that in here really quick. So it's not actually ever going to connect with the current settings that I have here. But we can save this out. Oh, you're not going to be able to see it. That's an issue. Let me see what I could do really quick. It is the reason why this is a little bit easier with a separate computer, but to expedite this, I kind of kept it on the same computer that I'm streaming off of. So I'm going to get a feedback loop if I do try and... Right. So I'm going to get a feedback loop if I do try and put it here. But let me do this. So now we have a cat. A cat in the shot. And let's see what I could do. I realize I'm looking at my keyboard too, so I can't even type in that. So, share the screen, I think, is the way to go. All right, before my cat makes a mess of everything. She's gonna start meowing the whole time. I hope not. Let's see. See if I can crop this really quick. Oh yeah, that's gonna work. That looks good enough to me. All right. So now we can see the screen. So I can actually save this out. So File, and we're going to save a copy. And we're going to save it to the Raspberry Pi Pico. And we're going to call it the secrets.py file. Boom, boom, boom. Which in this case, I actually already have it saved, so I'm going to keep that because I may be able to just use it. But this is what it would look like. And then we're going to come over here. This is our main.py. We're going to save a copy of this. And we will save it to main.py. Are we sure we want to overwrite it? The answer is yes. Otherwise, it's not going to do anything. And then we could try running it. And the big thing that we see here is that it says there's no module called Pico LCD 1.8. All right, and that's this right here, which is the module that we were actually trying to run. So this is LCD 1.8, which is a little bit different than what it specified here, but we can actually just go ahead and be able to define it. So we can actually just save this out as is, and the reason being is that because at the very bottom where it starts to do this, it says if the name is main. So if it's including it, it's not going to be that name will not exist. And we're going to call it LCD. We're actually going to call it the same name that it is. So we'll do Pico -LCD -1.8 .py. And then over here, we're going to update this name. And see if it works. It may not like the dashes. But something we do know is that in this file, it's actually LCD. The class name is this. So let's update this as well. But instead of actually just replacing LCD, because then we'd run into problems with the actual references, we're going to do LCD 1'8" as LCD. That way, all of the commands that they're referencing should hopefully still work. So let's save this out. We're going to overwrite it. And let's try running it. And we see we get another traceback error. Standard in, line 9, invalid syntax. So it doesn't like our 1.8. So let's save this out again. Boom, boom, boom. And let's actually make it the name that it thought it was going to be. And I'm going to copy this. We'll put it in there. Save it out over here. Replace this. We'll save it out again as well. Do main, overwrite, yes, run. Right, and then it wants the module ST7735 color. I'm not actually sure that it needs it. So everywhere where it defines that, we're just going to say LCD and replace it, because we know that earlier during our example we did LCD.white.black, etc., and that was able to actually provide us those built-in color definitions. So let's try that really quick. Right, so we're not going to include this library because I don't want to have to go find it. Save that out as main, and we'll run it. And what it's saying is the LCD 1'8" object has no attribute fill screen. And just for kind of a reference point, we see that nothing has actually changed on our display. It's still showing the example that we did before. So, but it's saying that that's happening. If we look at the traceback, it says standard in on 102 in module. So if we go to 102, we see update LCD, right, assuming brightness is 0, etc., blah, blah, blah. And then it's referencing 86 in update LCD. So update LCD, which should be coming from our, which is this function right here, 86, which is fill screen. So let's look at the example again and see how it filled the screen. So it didn't use fill screen, it just used fill. So let's correct this. So if we delete this, it's going to make the background white. We'll save this, because now if we look in Thony, the actual brackets up here indicate that it is actually saved to the Pico. So we can leverage that to be able to use that. And now we can run it. Next error is LCD 1'8" has no attribute white. So let's see where that actually was defined. Again, that was something that we changed. And it says it does. So we see LCD 1'8" has an attribute white, black, green, blue, and red. So let's see what it doesn't like here. And my feeling is because here's where we're defining it. So it looks like it's setting at runtime, so we actually should make this lowercase LCD. Because here we're saying lcd.fill, we made it a capital, which was assuming that it was a direct call to the function itself, to the library itself, opposed to it being to the individual implementation of that class. So now we made it LCD as a lowercase, we save that out. Let's run it. Okay, so we have a new error now. Excellent. And this is kind of the iterative process of, as you're going through, especially generating something with AI as assistance, you know, you're going to be doing a lot of debugging. So if you're good at debugging, then it's fine. If you're not really familiar with it, it's actually in a lot of cases better to write it to yourself from scratch to be able to get that kind of understanding of what the individual lines are doing, to be able to go through it more quickly, and then start adding AI as, you know, in small increments, either using it as a way to reference and get explanation for certain commands and functions, as well as, you know, augmenting your skill set as a programmer, opposed to trying to have it replace it outright. So if you think about this, I was taking a shortcut by using the AI, but the problem with that is that obviously I'm doing just as much work as I would have, you know, maybe not as much, but because I can go through, I'm pretty comfortable with troubleshooting and reading the tea leaves, so to speak, as far as the actual error codes are concerned. But, you know, it's still taking up quite a bit of time. It's not fully automatic. It's not there yet. So if we look, line 102 is still referencing set text color, which is not a thing, it's saying. So if we go back over to here, if we look at our examples, which is why I like to leave them in there, yeah, we see this is actually how it's defining the text. So it's it's creating the rectangles and filling them. So we can drag that over and actually apply that here to be able to do it, opposed to trying to do it this way. So let's go ahead and do that. So we said there were going to be 3 boxes. Look at that, we made 3 boxes earlier. How convenient. We're going to bring them in here, and we know already we have to change the LCD down to lowercase. So what I'm going to do is I'm going to do Control F in Thony, which gives us the option to replace. So we're going to do LCD, we're going to make it case sensitive, and we're going to replace it with lowercase LCD, which will be our call to our implementation of the class opposed to the class itself. So we'll find our next instance, we will hit replace, find the next, replace. I don't want to do replace all, and the reason being is that it could go out of bounds outside of my selection, and I would have absolutely no control of it, and it would be very difficult to get it back. So I'm just going to go individually. Even though it takes a little bit longer, it's actually faster in the long run because of that. Boom, boom, boom. Okay. So we replaced all of those instances. So now we have our 3 boxes that we actually want to put in. And we're going to put in this text here. So we're just going to copy this, put it up here, copy this, put it here, copy this, and put it there. We'll leave all of the other values the same. And then we're going to delete this original text down here because it's now, we know it's not working, we've replaced it effectively, and we don't believe that we will need to actually go through and reference it any further. So we're going to save that out, and we're going to run it. Now, if we actually look, we don't see any errors anymore, but we also don't see any display output. So something has gone wrong, but we don't necessarily know what it is. So we need to actually find out what's going on. So let's run it again. And in this case, it did pop up with an error when we did do the when we did run it, but that's relating to the way that it actually does that is it will send a keyboard interrupt, which is the same as hitting Control-C to actually do it. And that is why that's showing. So it's just because we ran it again. But otherwise, it appears to be running without an issue. But we don't necessarily know what it's doing right now. You know, that could be an issue. So we want to add some additional debug information to be able to tell us exactly what we're doing at any given time. Because it may just be that it's slow connecting to Wi-Fi, it may be it's not connecting to Wi-Fi. So we want to make sure that we're seeing as best as we can the actual steps. So let's scroll back through over here, and I don't know if I had it up at the time, but this is the traceback I was referring to with the keyboard interrupt. So we want to add some print statements to be able to do this. So let's go through. Let's see. So I'm going to check my syntax really quick. So what I asked ChatGPT was if I wanted to create a debug output to console, how would I add that? And it gave us a really nice example. Oh, it's going to do this forever, but I can at least stay here. So what it said is that we can create a debug mode flag, as it's called, and be able to have a debug message function that we can then call. And what it is if debug mode is active, it will print whatever the debug message is. And then it gives us an example. So for wireless LAN, we can add debug connected to Wi-Fi, debug connecting to Wi-Fi, things like that. And I like that a lot because it makes it so we can turn it on and off if we don't want to see as much noise inside of our console as we're going through it. So let's go ahead and add this right now. So we can copy that the contents of that, go over to Thony, and we can define that. We're going to put it right at the very top. Right, so we'll add our debug function right there. For my own sanity, I'm going to move the soldering iron out of the way. Okay. And then we'll go back over here. And let's look at our implementation. We have connected to Wi-Fi. Go back into Thony. We'll add our debug there. Oh, and actually it put it inside of is connected. Let's match what it has, right? So we have connecting to Wi-Fi down here. And then after it exits this while not connected, we have that it's connected. Let's start there. Let's see if it works. We will save that out. And if it gives you that error right there, usually you just have to hit stop, and then you can save it. But we'll run it. And let's watch on this debug terminal down here. Because if it's running, it should say connecting to Wi-Fi. So already we see that maybe the issue is that we're not actually doing anything, which is entirely possible. So we see down here with main, it should connect to Wi-Fi. We have it defined. We have while is not connected times sleep 1, IP address, all of that, and then update LCD. So we kind of get an understanding of exactly what we're seeing. So let's start here, and let's just go to basics and just say starting. Again, it won't let me. It says could not save, backend is not ready, so we have to hit stop. Then we can hit save. Then we can hit run. All right, and we see debug starting. So we do see it's reaching here, and then it's going to connect to Wi-Fi. But then when it's going up here, we don't see that it's actually making it to inside of this if statement. So let's place something here, and we'll say about to connect to Wi-Fi. And again, we'll hit stop, we'll save it, we'll play it. Okay, and we see in the debug terminal, it's starting and it's about to connect to Wi-Fi. So we are making it inside of this function, but it looks like it's not getting past this point. So it could be that our credentials are not being accepted, but it could also be saying that our wireless LAN is connected. But that may not be the case. So how can we deal with that? So if we go down here to the actual debug terminal and we hit Control-C, we can actually stop it at whatever point we're currently running. And then we have a Python terminal that we could just use normally. So in our case, let's replicate what we're doing. So we can import network. All right, and we can do the exact same steps. So I'm just going to copy from up here. We'll paste it down here. Make sure wireless LAN is active. And then let's just see what the value of wireless LAN.isConnected is. And it says it's true. It is. Okay. So it looks like it didn't have to do anything because it's already connected. So what I'm going to do is I'm going to move this debug command so it actually goes out a level so it's not subject to this if statement, because if the if statement is true, then clearly it's already connected. And again, we're not inside of an active program, so I can just save this. It will actually do it, and then we can run it again. Right, and it says connected to Wi-Fi. Okay, so it completed that function run and returned what the current value was. So this is working as expected. So let's add some more debug commands down here to see exactly what we're doing. So theoretically, we know it's connected, so it's not going to sleep. So let's find out what our IP address is. Let's try that, assuming it's not bad syntax. And that's my fault. Let's see. I'm actually going to replicate this formatting up here. Just because it's going to be easier. Okay, and we'll run it again. Excellent. So now we have an IP address that's actually running. Look how happy it is. I know I'm happy. So we can actually go to this IP address now. And theoretically, because it's not showing any errors, we can actually go through and be able to use it. Perfect. So it is running and it's serving a page. The problem is we don't have any content to serve back. So let's add some. So we would do that here because we saw that this is the code that it's actually providing to us. So we'll put it in H1 and let's call us the lighting dimmer. Right, and let's start there. Let's make something show up on the screen. So we'll stop it, save it, run it. Go back over here, F5. Might have gone too fast for that. I did. And what it's doing is it's exiting immediately. And likely what happened is that it's actually having a problem binding to the address. So we see right below here, it's actually trying to update the LCD. So we do see update LCD is not working, because if we actually show this over here, it still shows our original example, because we haven't removed power from this, so there's nothing to reset. So we may have an issue with that. But we do see it is showing us our current IP address. So let's find out what's going on with LCD before we start doing the web. Yeah, because that's got its own issue. So update LCD is right above this, which is a lot more convenient. Let's add a debug command over here. And we'll say updating LCD. We know it's not running because we're back at the command prompt over here. We're going to save it out. We're going to run it. Okay. We see we're at updating LCD. LCD did not update, which is fine, which means we're missing some commands from our example that are not within our actual code down here. And my feeling is that it's a push command to actually activate the commands that we just staged. But that's fine. You know, we can fix that in a second. But I'm willing to bet, because we did not come back to a command prompt, that now we have this. And there it is, our lighting dimmer. So it did run successfully. So what happened there? And I'm just going to kind of save some time and just go through what usually happens with running web servers on machines that you're not doing a hard reboot in between each upload. And that's every time that it tries to create that web server, it has that bind function. And that bind function is going to try and reserve a port to register a service to respond to requests coming in on that port. And the problem is it doesn't always close immediately. So sometimes it may take like 1 to 2 minutes to actually get through and close. And because of that, it won't be able to re-register a new service when it restarts and we rerun the program until that times out, and now it goes back to being available and we can re-register it again. So that's what it was. We have to add verbosity in our actual debugging to be able to give us that information up front. But it's certainly something that we can go through and troubleshoot as we go. But since the whole purpose of this is about the LCD screen, let's make sure the LCD screen is updating, because we're not going to get through the entire project today, but at least we can kind of get a good head start. So let's see something on the LCD screen just to kind of refocus our efforts. So update LCD, okay, is where it got to. If we go back over to our example and we look at the place, we have LCD show, which is not in here. So after we did LCD fill, we would need LCD show. So let's add that. In this case, I don't know if you saw that, but down here it showed I did the keyboard interrupt. It's because I did Control-C in order to copy, and that caused it to exit the script that it was running. But that's fine. We're going to have to do that anyway when we restart the script anyway, so we might as well give it a second. So let's go back over here, find what else we're missing. So after each command, we have to do LCD show. And then there's an LCD fill, but I'm going to see if we can avoid that, because that has a time sleep command, which is going to make this take a long time to update. And if we want to have it update every second, that doesn't really help anything. So let's just try and do it without it. So LCD show, and then we'll do LCD show again. And what it's going to do is it's going to blank the screen and redraw it. And that's what it's going to do. So we'll save that out. And I'm going to run it, but I'm going to switch to the overhead cam really quick. Zoom in here. Let's see what it does. Oh, we got an error. So it's saying function takes one argument. So it's pointing to on line 125 in module, and anytime it says on module, it's referring to the main script. And then that refers to line 100 in update LCD. And it says function takes one positional arguments, but 0 were given. So LCD show, and you know what it is again, we didn't change it from capital to lowercase. So let's just go ahead and change that, so that way it matches our implementation of this particular class. Right, it's already errored, so we can save it out directly. We can hit play again. Oh, and I should have done the overhead. But what we see is that now it's updated the display. It's showing our current IP address, and it's showing our two LED percentages as far as what the current values are. So we've been able to successfully update the IP address. And I'm just going to stop it again really quick. And I'm going to rerun it. And we see it does flash for a second, but it is updating the display the way that we want it to. And the nice thing is that because we're able to control the background, things like that, also use those hex values for colors, things of that nature, we could potentially have the colors be indicators for what the current status is. So if it's completely off, we can make it show up red. If it's on, we can make it show up green. However we want to do it, we can make it so that's how it will actually show. So it gives us a lot of flexibility as far as how we're using it to be able to display the type of information that would be the most useful to us. So I think I'm gonna we'll go for just another second here. I know nobody has any questions, it looks like, but if you do, feel free to pop them into chat. I am watching it. So let's add just another debug since we put updating LCD. We see it's only doing it one time. We could add another one for complete. Still busy. We'd have to stop it, save it. Right, and then we're down at the web server. So the LED 1, LED 2. So let's go back up to our LED web page. So what it's saying is that if we have a, sorry, if you see this here, so we have LED 1 and LED 2 as far as our possible handleable requests. So that's for our web server, and we want it to actually go through and be able to do something with this. So it's going to call the fade LED, things like that, which will be very nice. But we actually need a way to get to this. So /LED1 has to have a value. So let's try adding a button. This is not HTML. Well, maybe it is. Let's see. So I'm going to try just a button call, which is HTML5. And then we're going to do an onClick, which is JavaScript. And then we'll tell it what we want it, what the URL is going to be. And it's going to be / LED1 equals 100. And we'll say on. And we will copy and paste this. Make it 0. And say off. And start with that. So we'll save that out. We will run it. So now we see our LCD screen is currently showing 0%. If we go over to here and refresh this page, we now see we have 2 giant buttons. So we will press on. Still shows 0%. So let's go over to Thony. And we see we have no actual commentary here to be able to determine exactly what it is. And just so you know, when it says get, it's just referring to something that's actually in the URL. And I did question mark to denote the variable. So let's actually just go ahead and pull up ChatGPT again and just ask it, can you write an example of HTML that would set the brightness? Right, and this should be based on, because it's the same thread in ChatGPT, it should keep in mind what the current syntax is that it actually wanted to use. And this is ChatGPT 4, so it's a bit slower than ChatGPT 3.5, but we cut it slack because it's doing a lot of work for us. So what we see here is that it's quite a bit different in terms of the handle request function than it initially defined, because it was missing stuff, which is why I thought it was a good idea to just go back to the source and get it to fix its own errors. But this is a good chunk of code. So let's start with one LED at a time. So we'll include the whole thing actually. We'll go copy this into Thony. And it did H2 as well, so. But we'll just put that there. Just because I'm retentive like that, I'm going to make it so it's the same tab indent, just because it's going to make life easier. So we'll just do one LED for now. Okay, so form action is set LED, method is get, etc. Right, and then the handler for that will be this new definition of what handle request is. Right, and it's everything above the response. So I've copied that. So handle request right here, everything above. Right, so now we've added this. So notice it adds a lot more complex type of operation. So set LED in request, and then it will split it by certain variables to be able to extract that particular variable or that particular value that we want to utilize, and then from there be able to apply it to the variable. So we're going to stop the execution, we're going to save it, we're going to play it back. Okay, we have no errors. And if we look at our LCD screen, we see it's currently showing 0%. So now if we go back over to our current display, let's set this to 50% and hit set. And if we go back over to Thony, it did exit. So there is an error in here. So we need to add more as far as our debug commands to be able to determine what it's doing. So we'll add set LED. It's going to have a params dictionary. So let me actually move this down so we don't get additional errors. And we'll see exactly which LED it's trying to modify. So we will save that out, hit play. See if this is ready to rebind. I can tell it's not because it went back to a command prompt. So we're going to stop it, try and run it again. And when all else fails, just unplug it and plug it back in, because that will clear out the socket guaranteed. So we're going to stop it right now, and we will hit play. Okay, and we see now it doesn't have... Oh, and it did try and set the LED, but it exited. So we see it got through set LED, but it never got through here. So what we can do, and this is something that often happens, is doing a try. So a try and accept. And we'll just say set LED problem. Now, we do need to tab everything underneath the try in order to do it, but this should actually prevent it from unexpectedly exiting the program, because anywhere in the program, anytime there is an issue, it will just exit it outright. So it's certainly something you want to make sure you're trying to make it run as best as possible. And in our case, here the reason it is actually exiting out to console after it tries to reinitiate the web server is because we don't have a try except there. So for example, if we did put I'm actually going to put here So what I'm going to do is I'm going to put this in its own while loop. So I'm going to do while retry. Okay, so what I did right there is I made it so while retry, try s.bind to address, and if it succeeds, it will not escape out and go to accept, because if this command fails, it will escape out and just sleep for a second and retry it. But if it does work, it will set retry to false, which will break this loop and continue on. So let's try this. So I'll save this out. I will run it. Now the only issue here is I actually didn't put a debug to let us know that it's retrying. So let's go ahead and put that. So we're going to put trying to bind web server. Oh, it says it's busy because I didn't stop. So we'll save this out and run it again. So in this case, it didn't exit out. It says trying to bind a web server once, and then it's complete. And actually we could put that as well. So I think that'll be a very nice. Right, so updating complete. Trying to bind a web server, bind web server complete. So now we know that when we go here and we reload this, this will come up as well. So we can type 50 here, hit set, go back to Thony. Thony tried it multiple times. It said set LED, LED, set LED problem. Set LED, set LED problem. So we definitely have an issue with our parsing code, because we never actually reach here. We're just exiting out. So we could find out if it's between the first command or the second command by going here And we're just going to say LED params. And we'll go here. LED params underscore dictionary. And let's actually make it so it matches the variable. Device is busy still. Right, and we see it's currently trying to bind a web server. So we'll give that a second here, see if it does it on its own, otherwise we'll reboot it. This is exciting stuff, right? And if we look at our front screen, we do see it is updating correctly, but obviously we haven't changed anything. So I think we may need to reboot the do actual hard boot. So let me show you what I'm doing. Right, so we have it powered through the Pi Pico. So I'm going to unplug it and plug it back in. Okay, so it comes up with this, which is just a bunch of noise because we're not running the script yet. And in this case, I actually don't think main.py is appropriate for the Pico. I think they do have a different default name for the default start script. So just something to keep in mind. So we'll go back over to the computer. We will run it from here, and I'll show you it starting. Oh, and I waited too long. Sorry. Okay, I'm going to press that button again. Right, so we do see that it updated, and when we go back to the computer, we do see that it says bind complete. So let's try going back over here. I'm going to refresh this page. I'm going to type 50, hit set, go back over to Thony, and we see it still has that issue. So we're not actually updating what we need to, but what we do see is that it's actually not getting past the params where it's doing the request split 1 based on spaces. So, bit of an issue. Let me see if I have another script that we can pull up really quick. All right, and this particular script is one that I've actually done, which is quite a bit more advanced based on the same principle. That is a remote cat door opener. So it will automatically open on time, it connects to NTP, it does syslogging, everything else like that. So quite a bit in terms of what the actual capability is for this respective little tiny computer. So let's continue down and take a look and see what we can find from here as far as how I split out those particular values. And we see a lot of things here. I did request.find to actually find out exactly what it was going to use it for. So if we look at not door open, like we'll do NTP set address. Well, that's annoying. Let's see. So here, NTP set address. This is how I actually got the value from it. So if we go back over to our function here, if we look, the way that it's actually setting the brightness is that it's doing set LED method get, but then it's doing brightness 1 as the label. It's doing brightness 1 again, brightness 1. So brightness 1 is actually the name of the variable that we're trying to find. So this looks actually very complicated, what we're trying to do up here. So let's try this. So if we look at over here, we see set /set LED and then question brightness and then LED number, which it seems kind of redundant that we're doing it this way, but where it's defining both the LED and the brightness with the integer next to it. But that's fine. I mean, it's just question mark and then we want to get the equal sign. And we may need to actually modify what our form field is in order to make sure that it's going through. But let's start here. And let's see what our params are actually outputting. We'll save that out. We'll run it again. It's able to bind. When we go over here, I'm just going to load this from scratch. And we'll type in 50. Alright, so it did something because it loaded back to the original page, but it says set problem. So it's never actually making it here. So something is not particularly happy. So let's actually try this. Let's debug and tell us what the request is. Because at least that way, if we know it's getting to this point, we'll be able to know what we're working with. So I'm going to stop it, save it, run it. Now it's trying to bind to web server. I'm going to stop it again really quick. Just give it a second and let's try running it again. That's fine. Gonna reboot it. Okay. So now it's running on the web server. We can go back in. I've already set it to 50, so we're just going to hit F5. That should have run it. Now over here, we see exactly what our request is. And we see it's very noisy. So we see favicon, things like that. So favicon, obviously, we want to ignore. And here's the one that we actually set. So here's the set LED brightness 1 equals 50. So we see the data is making it to the Pico. We just have to be able to extract that. And we see there's a lot of additional information here, separated by spaces. And it shows us that the referrer is the root of the web address. So the first thing that we want to do so we have brightness 1, which is spelled correctly because we did a copy and a paste. We're going to take everything after it, which is the 1. If we did a 0, it would be everything before it. We have the split by space after that, and we're taking everything before it. And that should actually give us 50 and LED equals 1 as our actual values coming out. So in the event that we can't get it to run like this, because we keep running into LED problem, what it's best to do is to simplify the command that you're using. So let's go ahead and copy this out. I'm going to comment it just so we have it for reference, and I'm going to delete the last split command so that way we could see and then compare what we're getting after we run that first split. So we'll save this out after I stop it. We will save it and run it. Go back over to our web page. I'm just going to hit F5 because we've already got everything there. All right, and then we see the first request that comes in is our thing. So it's still running into a parsing issue associated with this particular text. So it's not doing the initial split. So let's try this. Let's try doing the entire